Welcome. Today you're going to be learning about inverses. Let's say I've got a function. There's my function f of x, and I plug 4 in, just like a function machine, and we get out 14. Well, an inverse is if you took 14 and plugged it in, the output, and you got back the number you started with, 4. See how those are the same number? Okay, so a good definition of an inverse is it's a function that undoes another function. Okay, my function on the right there, the f with the little -1 to the power, that's not actually a power, it's just a notation for an inverse, alright? That function on the right, that's the inverse of my first function, because it took the 14, the output, and it gave me 4, the input of the first function, okay? Another way to look at that is two functions are inverses of each other if you can switch the input and outputs, okay? So the input of one is the output of the other, and vice versa, alright? Let me use a real-world example to explain one little trick when finding the inverse, alright? Let's say you want to put socks and shoes on for the day. Well, the first thing you would do is you'd put on your socks, right? You'd follow that by tying your putting on your shoes, and last step would be tying your shoes. Now, if you wanted to undo all of that, you would have to do it in the opposite order. You couldn't start by taking off your socks. That would be very silly. So you got to take your shoes off, or sorry, you have to untie your shoes first, then you have to take your shoes off, then you have to take your socks off, okay? Notice, the important thing for you to notice is that when we're undoing stuff, we're doing everything in the opposite order, okay? Look here at this, you see the two functions up here? The first function, when we do 3 times x plus 2, in order to undo that, we have to undo the very last thing we did. Okay, we've got to undo the plus 2 first. That's why you do x minus 2 first, and then you divide by a 3. Alright, and it makes sense that multiplying, the opposite of multiplying is dividing, and the opposite of addition is subtraction. Okay, each of those undo each other, but the order that you undo it is very important. And finding out how that order works, that's the next trick we're going to learn. Okay, so here I've got a function f of x equals 7x minus 5. The first step you need to do is you need to replace that f of x, replace it with a y. Okay, we've kind of learned those are pretty interchangeable. They mean slightly different things, but yeah, for these functions you can replace one with the other. The very next step is going to be something a little weird. You can think in math, but yeah, I want you to switch the y and the x like that, okay? So we have x equals 7y minus 5. Just switch that x and y every time, okay? This is to find the inverse. Then the last step is we need to solve for y. So here we are solving for y. You can follow the work along if you want, but notice at the very end I put the x plus 5 over 7 equals y, and the f to the negative first of x, that's just another way of saying the inverse, okay? And that's what I'd like for you to write at the very end of each of your problems, okay? Saying, letting me know that that is the inverse of f, okay? One little thing about this is we can use our input-output switcher to check our work here, okay? So when checking my work, let's say pick any number, 2 is usually a good number to pick. We'll plug that into f, okay? So it's 7 times 2 minus 5, you get 9. You then take that output and plug that into the inverse, the function we just found, x plus 5 over 7, okay? And if you plug that in, we plug in 9, you get 9 plus 5 is 14, divided by 7 is 2. Well, look, that's the very first number we plugged in. If it's not the very first number you plugged in, then we probably made a mistake somewhere. But that is an excellent way to check your work, just by plugging in a real-world number and making sure that the input of one is the output of the other. Okay? Here, I'm going to pause the video, or I want you to pause the video and try this one down here. Okay? The one just below it. Alright, hopefully you got that one right. We'll move on to the next one. For this one, I know it's hard to see, so that's supposed to be a cube root of x minus 1, okay? So we start by replacing the f of x with y, then just switch the x and the y, alright? That funny step. That's the step you got to remember for these inverses. And we're going to solve now for y, get y by itself. When you get y by itself, you get x cubed plus 1, and that is the inverse. All right, I'll leave it to you to check your work if you'd like to practice that. I'd highly recommend that. But go ahead and also try that function down there at the bottom. Alright, hopefully you got that one right, and let's do this last one here. Again, replace the f of x with y. I'm going to switch then the x and the y. That's the next step. Okay. At this point, the reason this is a little more difficult problem is because we now have a y in the denominator. So to get that out, I'm going to do this, multiply both sides by y. I know some of you will probably try to multiply by 5, but remember when you multiply by a number, it gets multiplied by the top, by the numerator. Please don't do that, because that is not going to get that y out of the denominator. We can divide those y's out, so we get y equals x minus 4, or y times x minus 4 equals 5. When you do the rest of the work, I'll let you check it. You get the inverse is 5 over x minus 4. Sorry that my work ran over there, but go ahead and try that last function there as you can. Alright, now that you've tried that one, hopefully those three are doable. They're more practice problems than your textbook will do later. The next thing I want to look at are the graphs of inverses. Okay, so I'm just going to plot 2x plus 1 really quick here on the on my grid. I found it by finding the y-intercept and the slope. You guys know how to do that. And one neat trick you can do with Desmos, okay, if you type this into Desmos, you can actually just switch the x and the y in Desmos, and it will graph the inverse for you most of the time. Okay, for all the examples we're doing, I believe it will work. That's a nice little handy trick when you're checking your work, at least to use on Desmos. Go ahead and type that into Desmos, and we can pause the video, and I want you to describe how the second graph relates to the first. Okay, so go ahead and type that into Desmos. Alright, if you type that into Desmos, hopefully you got an equation that looks like this. Okay, the thing I want to point out is look how we started with these points, and I'm just going to pick on one point here, 1, 3. That became 3, 1. Okay, and that's true for every single point on the graph. It became the exact same point, only you switched the x and the y. You switched the input and the output, which goes back to our definition of an inverse. It's the two functions where the input and the output are switched. That's a nice way to graph it, especially if you can't see what we're actually doing here. Another way to see this is we're reflecting it. Yeah, x and y are switched. We're reflecting it over this line in the middle here. Okay, that's the y equals x line. If you can visualize those reflections, that's great. But if you can't, what I would recommend is start by taking several points, just switch the input and the output, plot those points, and then just connect the dots. That's a great way to graph the inverse. Okay. Go ahead, and I'm going to sketch this next one here. Go ahead and try typing that into Desmos again with the x and the y switched, and see what the graph, see which graph it gives you. Okay, you can pause the video real fast. Alright, hopefully you got something like this. Okay, there's two ways to do this. You can pick a point and graph the inverse of that point each time and then connect the dots, or you can visualize the reflection over the y equals x axis. Okay. Alright, for this third one, I'm actually going to do this just by reflecting. Okay, we make x cubed, and yeah, that took me several tries. So don't worry if you don't get it in the first one. For this, I want to flip this over the y equals x axis. And can you see how that the top that goes really high up there is actually going to go way to the right, and the one that goes really far down is going to go really far to the left when we flip it over that x equals y axis? Okay, that's what it's going to look like. That's a little bit harder to do because there aren't nice, easy integer points on our graph to plot. But again, you can use Desmos to check your work by switching the x and the y on Desmos and making sure that's what that looks like. Alright, go ahead and try these three on the bottom, and make sure you come to class ready to discuss them and share them with your partners. Alright, for this last one, we're going to talk about restricting the domain. Alright, I went ahead and graphed x squared there. I want to flip that over the y equals x axis. And can you guys see what that would look like? I just plotted the points I wanted to flip, which was easy for me, and connected the dots. But we have a problem here. The problem is this is not a function. It's not a function because one reason is because it doesn't pass the vertical line test. All right. This actually leads us to an interesting thing we can do with our original function. Okay, we have a horizontal line test we can do. If a function hits more than one point, when you stick a horizontal line through it, then the inverse will not be a function. Okay, so in order for it to, when we reflect it or when we find the inverse and graph it, in order for that to be a function, we need to do something called restricting the domain. On this second graph, we're going to restrict the domain by making x only greater than 0. Okay. Here I'm going to sketch just the x values that are greater than 0. I guess I technically did greater than or equal to 0. And yeah, I'm going to reflect that over the y equals x axis. Okay. That reminds me of a joke. I want to give you guys some jokes since most of this is probably a little boring for you. How did the chicken find the inverse? Well, it reflected the function across y equals eggs. Okay, enough of the jokes. Look, we found a function. It's a function now because we cut off half of it and it passed the horizontal line test, so the inverse, the red function, will now pass the vertical line test. Whoop-de-doo. I want you to try that last one before coming to class, and you're going to share that with your partners on those first 10 minutes of class. Alright? Hope you enjoyed this, and thank you for watching.